Let's walk through pull request 329,782 from the VS Code repository. This is a focused fix addressing a race condition in how chat tools are invoked, especially important for dynamically registered tools like those from the Model Context Protocol. This PR has one primary goal and two supporting objectives. First and foremost, we need to re-resolve the tool registration right before invoking it. That's the core fix. We also need to make sure the updated tool reference is used everywhere after invocation, and we're adding tests to cover both re-registration and removal scenarios during the preparation phase. Here's the scenario we're fixing. The original code captured a tool reference when the invoke tool method was called, then ran a potentially long async preparation step. If a tool was re-registered during that preparation, which can happen with Model Context Protocol tools that refresh their metadata on demand, the code would still invoke the old stale reference. Even worse, if the tool was completely removed, the invocation would attempt to call something that no longer existed in the registry. Let's look at what changed. We're working in two files, both in the chat tools subsystem. The main service file gets the refetch logic and the active tool variable propagation. The test file adds two new test cases to verify the behavior when tools are re-registered or removed during preparation. The first change is subtle but important. We introduce an active tool variable right at the start, initialized to the tool reference we just looked up. This variable will track the tool implementation that actually gets invoked, which might diverge from the original reference if the tool is re-registered later. Here's the heart of the fix. Immediately before we invoke the tool, after the async preparation phase has completed, we refetch the tool from the registry. We check that it still exists and has an implementation registered. If the tool was removed, we throw a clear error. If it was re-registered with a new implementation, we update active tool to point to the current entry. This closes the race window. Once we have the correct tool reference, we need to use it everywhere. This diff shows the post-invocation handling, compression checks, telemetry, and tool details. Every reference to tool.data is replaced with active tool.data. That way, if the tool was swapped during preparation, all the logging and metadata accurately reflects the implementation that actually ran. Two new test cases lock in the behavior. The first test disposes the original tool registration inside the prepare callback, then immediately registers a replacement with a different invoke result. The test asserts that the replacement result is returned, proving the relookup worked. The second test disposes the tool without re-registering it, and verifies that invoke tool rejects with a not contributed error. Together, these tests cover both branches of the revalidation logic. Here's what we've achieved. Tool invocation is now safe for Model Context Protocol and other systems that refresh tool registrations on the fly. The tool is revalidated right before invocation, so if it was replaced during preparation, the new implementation is invoked. If the tool was removed, we get a clear error instead of attempting to call something that doesn't exist. All telemetry and post-invocation handling uses the correct tool reference. This is a clean, well-tested fix for a subtle race condition. The code revalidates tool registration at exactly the right moment, the active tool variable propagates through all the right paths, and the test coverage ensures both the happy path and the error path work correctly. No gotchas identified. This is ready to merge.